Doubts are taken for the previous class. Diagrams and charts are shown for talk. Refer to the chart, 5:26 p.m. Geo Transfer Orbit. To attain geosynchronous or geostationary, a satellite is first placed into a highly elliptical orbit whose perigee can be very less, but the apogee will be in the range of 36,000 kilometers. When the satellites reach the apogee, they can be given a boost so that they can achieve the desirable geosynchronous or geostationary orbit. The intermediate orbits are called Geo Transfer Orbits. Sun-synchronous orbit. In a sun-synchronous orbit, satellite orientation is fixed relative to the Sun throughout the year. Thus, whenever a satellite crosses a point on Earth, Sun's position in the sky is almost the same. Hence, satellite will cross the point Earth at the same local solar time. This is a very useful characteristic for Earth observation satellites because scientists can collect data across several years and compare the changes for a particular region without worrying about extreme changes in lighting and shadow. How to achieve sun-synchronous? Earth is not a perfect sphere. Because of this, satellites' orbits often do not remain fixed. Orbit in itself starts rotating. Such type of motion is called precessional motion. Generally, the precessional motion of orbits is not desirable. In a sun-synchronous orbit, we make it desirable. Earth's position concerning the Sun changes also because of Earth's revolution around it. If we can achieve a precision that cancels out the daily change in the position of the Sun because of Earth's revolution, we can achieve sun-synchronous. It is often achieved at an inclination of 94 to 96 degrees. Because of this, it is also called a polar sun-synchronous orbit. Height is 500 to 800 km. With 1 degree of precision every day, we can achieve sun-synchronous. Types of satellites. Mainly 3 types of satellites. A. Communication satellites. B. Earth observation or remote sensing satellites. C. Satellite navigation. Communication satellites. These satellites maintain a communication channel between 2 points on Earth that are far away from each other. They are often placed in geosynchronous geostationary orbits. ISRO has one of the most extensive communication satellite programs named INSAT in the Asia-Pacific region. Recently, ISRO has changed the nomenclature from GSAT to CMIS for communication satellites. Applications: radio, television. Education. ISRO under EduSat Pro provides satellite-based instructions for free throughout the country. Healthcare. With help of satellites, rural hospitals and colleges can be connected to specialty hospitals in cities. VASAT, very small aperture terminal. These are ground stations with small antennas, 1 to 4 meters, that can maintain satellite connectivity, and with the help of these stations, we can transfer data from one location to another. COSPAS Sansat. It is a satellite-aided search and rescue program. With the help of an emergency beacon, an aeroplane or a ship or even a person lost in remote areas can be located. India is a member of this program. Earth observation satellite. These satellites, with the help of powerful techniques such as radar imaging, synthetic aperture radar, light detection and ranging, spectroscopy, and hyperspectral imaging among others, can collect data about a particular region of the Earth which can be used to determine physical, chemical, even biological properties for a particular reason. It can be useful across many areas such as A. Soil monitoring in agriculture. B. Geology and geomorphology. C. Environmental monitoring such as forest. D. Renewable energy capacity. E. Ocean sciences. F. Weather information. G. Natural resource monitoring. H. Disaster management. I. Implementation of government schemes. ISRO has dedicated satellites for different objectives. Recently, ISRO changes the nomenclature of satellites and they will be called EOAs. They are generally placed into LEO, polar sun-synchronous orbit, and sometimes even in geosynchronous, geostationary rotations. NISAR mission. Record fine images. It is a remote sensing technique. NASA and ISRO have collaborated. Objective: disaster monitoring and environmental monitoring.